Hello, everyone, and thank you for joining for our session, Extreme Elasticsearch Performance with Lower Costs Using Cloud Volumes ONTAP. I'm Pavel Klushin, a product evangelist in the Tel Aviv Innovation Center. With me today is Aviv. Hey, Aviv.
Hi Pavel and hi everyone. My name is Aviv Degani. I'm a Cloud Solution Architecture Manager for the NetApp Innovation Center. And today we're going to talk about how we improved our Elasticsearch service time by almost 300% while adding more logs retention, while actually reducing the total cost of ownership. And then we'll also show you an Ansible playbook to automate the entire deployment in like 20 minutes or so. By the way, this session is confidential, but please tell everyone about it after or during the session. Cool. Today we're going to briefly explain about Elastic and the challenges around it, the technology to address many of those challenges, the architecture and the test we use to boost our performance and the ability to save more logs, and we'll end this session with some code. So we got only 20 minutes, so let's kick it off and get started.
Thank you, Aviv. Now let's discuss why should you use log analytics? So application servers, cloud infrastructures, microservices architecture, those are the biggest businesses and IT trends that are helping us to improve operations and customer experience like never before. But those trends have also resulted in an explosive growth of machine-generated data, which includes logs and metrics such as user transaction, customer behavior, sensor activity, machine behavior, and security threats. The data is complex, but is also the most valuable as it contains operational intelligence for IT, security, and businesses. Log analytics includes searching, analyzing, and visualizing machine data generated by your IT systems and technology infrastructures to gain operational insights. Traditional data analytics tools are simply not built to handle this variety of volume and rapidly growing machine data. Elasticsearch is the most common service that collects, indexes, and unifies logs and metrics across your environment in order to give you visibility into your applications and infrastructure. Let's move on and see the Elasticsearch architecture. As you can see, Elasticsearch is built with different kinds of layers. The first layer is the edge machine, which you can call bits. Bits are the log agents that are collecting the data. Those log agents are transferring the logs into Elasticsearch. Elasticsearch is the engine that collects those logs and indexes them. Then, in order to view those logs or build some kind of dashboards from them, we are using Kibana. Kibana is the tool that allows you to view the logs and build different dashboards and connects very easily into the Elasticsearch. Now that we saw the architecture and talked about the log analytics challenge, let's see what are the Elasticsearch challenge, because Elasticsearch is great, but it comes with many different challenges. So first of all, users want their system to be fast. And that means that we need to provide them a fast searching engine. And as we mentioned before, the data grows massively. I've seen many customers who write more than 5 terabytes every day to their cluster. When the data grows massively, we need to add more compute and more storage in order to handle this massive growth. But as you know, adding more compute and storage is not cheap at all, even if we're talking about cloud services like AWS, GCP, or Azure. And as you saw in the previous slide, Elasticsearch has many different moving parts: logs agents, Elastic Agent, Kibana dashboard. Each one of them needs to be maintained, upgraded, patched. And as you all know, operating a production system that has many different parts is very complex and requires a lot of attention. This is why many users choose to go into the managed services solutions, but of course, managed services comes with high price as well.
And this is why many times what people will do is to deploy their Elastic nodes on EC2, and they will use native EBSs as the underlying storage. It's because they want to save the cost and they want to optimize the deployment, right? Now, don't get me wrong. Using EBS is easy, but I want to offer you a much better alternative for the underlying storage layer, Cloud Volumes ONTAP. Cloud Volumes ONTAP, or in short CVO, is a fully fledged version of ONTAP. It's the same ONTAP that NetApp has been developing for almost 30 years now, just that instead of installing it on a FAS or an AFF, it consumes native cloud resources and it runs as a virtualized storage appliance on any of the major three public clouds, AWS, Azure, and Google Cloud. You can see in this diagram that the controller is the cloud's compute service, so EC2 for AWS, VM for Azure and Google. And for the storage layer, it will be the aggregates from the cloud's block device and object storage as well. It's a mature, proven technology that exists for over 5 years now, and the majority of our customers are using it for production workloads. I think the reason the product is so successful is because it allows us to get an enterprise-grade data management thanks to ONTAP with the agility and flexibility of the public cloud. Now, what automates and orchestrates the deployment and the day-to-day management of Cloud Volumes ONTAP is Cloud Manager. Cloud Manager is a beautiful piece of code that brings the cloud closer to storage admin from one hand, and on the other hand, it brings the storage closer to Cloud Admin, DevOps, or SREs. It will take about 25 minutes for Cloud Manager to deploy a new CVO, and from that moment on, you will start getting all the ONTAP goodies. Multi-protocol access, instant snapshot, block-level replication across regions, ransomware protection of your data, instance cloning, and let's not forget storage efficiencies, which can save you for log analytics about 70% of your total TCO. We can also leverage local attached NVMe device to boost our cache, which is incredible for random read workloads. In recent performance testing we did, we got to 500,000 IOPS, 500k IOPS on a single CVO cluster that runs on a EC2 that can leverage just 80k IOPS. It's amazing. Add to that the fact that we can tier cold blocks into S3 automatically and seamlessly, completely transparent to the application. Think about it, hot blocks on NVMe device, cold blocks on S3. So in essence, you're getting NVMe-like performance with S3 costs.
Let's go over the test case overview that we have done. We wanted to show the power of CVO versus the cloud-native storage. So we have done two tests. The first one is with a read-intensive workload, and the second one is with write-intensive workload. So the first one, in this case, we wanted to show how faster we can get over AWS EBS GP2 storage devices. So we simulated a heavy search case using Rally. Rally is the Elastic certified benchmarking tool that they are using internally in their R&D center when they are providing new versions. The heavy search case was on a 420 gigs of dataset and an index size of 30 gigs. The Elasticsearch architecture was a single node cluster running on an R5 2XL instance, 2 terabytes EBS GP2, and on the other hand, we had an CVO running with an iSCSI protocol with also 2 terabytes of EBS GP2 provisioned in the aggregate. Now let's see the results that we have seen after the overview. So the results were quite amazing. As you can see in this table, we got 66 performance acceleration. That means that when a user is querying or searching in Elastic, CVO will provide with an answer substantially quicker. Also, we can see that CVO gives 86% more IOPS and the maximum disk throughput is bigger by 223%. Those are quite amazing performance results that we were tested in our lab. But we also mentioned that cost is a big issue for Elastic customer. So let's see a real success story that we have done with a real customer. So in this case, our customer is the latest acquisition company called Spot. As Spot helps to reduce the cost in our internal NetApp systems, we wanted also to help them to reduce their cost in their internal systems. So we migrated the Elastic environment from cloud-native EBS GP2 storage into CVO. Their cluster is a write-intensive cluster, which have about 50 terabytes of data, and their different microservices are writing 5 to 6 terabytes of logs every day. The log retention policy is 3 days and is used mainly for internal support teams and R&D troubleshooting. The storage cost is about $4,900 monthly. After migrating the cluster to CVO, we saw a substantial cost savings. So let's see the results. By leveraging theme provisioning capabilities that Aviv mentioned earlier, we were able to save them 40% of the storage footprint by keeping them on the same IOPS level that they needed. What's even more interesting here is that cluster was without any replication, which means that in case of an EBS failure, the whole cluster is not available. By deploying a highly available CVO cluster, we added a layer of redundancy to the solution. So to conclude, Spot is now having an elastic cluster which is 40% cheaper than before with a higher SLA, and now they can even keep more logs with the same price and support better their customers. This is quite amazing.
It is quite amazing and a great story, I must say. And actually, Jonathan is a PM for Spot. He just told me yesterday about the solution and how happy they are with it. And he also confessed that he had his doubts before. But I do understand where it's coming from, because usually the fear is around adding another layer of complexity around the solution. But it is quite easy, especially if you're using Cloud Manager and UI. And it's even easier if you're using Terraform or Ansible. I'm about to show you an Ansible playbook that with a single command will deploy the entire infrastructure in less than 20 minutes. No worries, I will fast forward most of it. And then I will show you a side-by-side comparison of an Elasticsearch heavy read workload on EBS versus on CVO. Cool, so with this playbook, all we need to do is to fill some vars in this inventory YAML. Information like the required VPC, subnet you want to use, the number of required aggregates as the factor of your required capacity and performance. All these variables will need to be filled. Also the number of iSCSI LANs and the IQN of the Linux clients. And then to actually run it, all you need to do is to take the following playbook, right? And then to add the inventory YAML I just showed you. So as you can see here, it's a very simple command to run it all. Now I'll run the command in my second screen and I'll switch quickly to Cloud Manager so you can see the actual CVO deployment. Cool, so with the new SaaS UI, all you need to do is to open a browser and go to cloudmanager.netapp.com to open the SaaS UI. You can see right away on the left cloud that we have a cluster during a live deployment. But for us to actually see the full audit of the APIs we ran and the responses we got, I'll access the timeline. It will always push the latest action to the top, and by clicking on the 3 stripes on the right, it will show us the actual responses we got. That's a great way to see the actual commands and responses so you can automate it by yourself. And cool, it's ended. So let's switch to Elastic. We're running the same workload both on EBS and CVO. At the top, it's native GP2s versus at the bottom, iSCSI on CVO. You can easily see a consistent search latency of 3 seconds versus an inconsistent latency that averages around 9 seconds for EBS. So it's much better latency and user experience for CVO. And that's exactly the difference between a user flow that keeps you productive versus a user flow that makes you mad, basically. We hope you took from this session that there's a better way to deploy Elastic in the public cloud, a way that allows you to save more logs while accelerating performance and reducing the overall cost. It's called Cloud Volumes ONTAP. So I encourage you to log into cloudmanager.netapp.com and to start your free trial. And if you have any questions, there's a blue circle in the bottom right side of the screen. That's an in-app chat directly with the Cloud Solution Architect team. Okay, it's not a support channel, so use it wisely. but you're more than welcome to ask us anything. So I hope you enjoyed and learned something new today. And please tell us what you thought about this session in the survey. Thank you again and stay safe. Peace.